Hi everybody, let's talk about hydration weathering. So hydration is a type of chemical weathering, and here are the steps laid out. Chemical weathering, again, it means any chemical reactions through water, acid, or air. With hydration, when you're hydrating something, you need water. So water is the most important thing in this process. So you can always visualize it in a diagram. The first step, the rock minerals absorb water. So you can draw a rock, a big rock, and you can draw minerals inside, such as like a square or something. So when you have absorption of water, you need a water source, and the main source of water is usually rainfall, precipitation. So you can draw rain up there, going downwards, and then it absorbs the water, so you can color it in maybe. A new mineral is formed, so you can't really visualize a new mineral, so we'll just move on to the next step, where the mineral expands and puts pressure on the rock. So this new mineral, because it has the presence of water, that means it has enlarged, so the volume is larger. So you can draw an outer line which shows its expansion with arrows. And that's basically it. You can draw cracks if you want. Just label it cracks. And yeah, you can put the numbers on. So absorption of minerals, so you can 1. New mineral, maybe this one is 2. And then the mineral expands, this one is 3. So I put here an example of hydration. It is when water reacts with hematite and it becomes goethite. So you can use this as an example in your exam. And here are the favorable conditions for hydration, so what increases the rates of hydration. The first one is high precipitation. So the more rainfall, that means the more water that is available for the minerals to absorb, and therefore the greater the rate. And if it's more acidic, then the reactions will take place faster, and therefore the greater the rate. Temperatures as well. Temperature provides you the kinetic energy, the energy for your chemical reactions, and therefore higher temperatures will help you increase your rates of hydration. Rocks with anhydrous minerals. So as you can see, these rocks, they have to react with water to expand. So anhydrous just means the minerals with no water or lack of water inside them. So therefore it is available, there's space for it to absorb water and expand. Else, if it's already hydrated and the volume is fixed for the hydrated mineral, adding water to it won't make a difference. And high surface area. So if your minerals are maybe dots, that means it's high surface area, whereas if it's just a square compared to a lot of dots, the dots have more surface area than the square, and therefore the dots, so the pores, the more granular the minerals are, therefore the greater the rates of the hydration. Also, it comes in with pores, how much pores are in the rock, or how much what's permeability of the rock. We'll go through that in our video about the factors that affect the rates of chemical reactions and chemical weathering. But this just sums up the hydration quite nicely with a diagram, and that's about it. That's all you have to know about hydration. I hope you guys enjoyed, and I'll see you in the next video.